Hello and welcome to this next video in the little series on mole calculations. What we're going to be looking at in this video is we're going to be looking at atom economy. So last time around we looked at percentage yield, which sort of told us how efficient a reaction is from going from the reactants to the products. What we're going to look at in this lesson is we're going to look at atom economy and what atom economy is and how to calculate that atom economy. And it's very closely linked to yield in the manner in which we sort of take all that information to decide which reaction is the best to use. So what is atom economy? Let's get started. So atom economy is simply a method of showing how efficient a reaction is at making use of the reactants. So if we were to look at an example, let's say the Haber process, which we've already talked about a couple of times, okay, but we've got nitrogen and hydrogen in a reversible reaction to form ammonia. This is a really important industrial process. Now, what atom economy is if we were to look at the sort of atoms within this reaction, so here's my nitrogen, let's just change colour for the hydrogens, we can actually observe how they are. So I'm just going to quickly draw this out. Okay, so here's our reaction. Let's look at it in a bit more detail. We've got our nitrogen atoms here, our hydrogen molecules here, and we've got our ammonia compound molecules at the end. Now, what we're interested in is we're interested in what we call the useful product. Now, the useful product in this experiment is our ammonia. So you can quite clearly see that this experiment only produces ammonia, which is brilliant. We can see that all of the atoms on the left-hand side are used in making the products on the right-hand side. Without doing any calculation whatsoever, because I know that all of the atoms in the reactants are used in the product, this reaction has an atom economy of 100%. Okay, so this is 100% atom economy. Now, where does the calculation fit in? Well, the calculation fits in, and I can talk about it now with this 100% to prove to you it's 100%, is that the atom economy equals the MR, okay, or the mass, okay, the total mass of the useful products divided by the sum of the masses of the reactants. And it's a percentage, so it's multiplied by 100%. Okay, so just a little reminder, this MR, okay, this can be the relative atomic mass, the relative molecular mass, or relative formula mass. In this case, it would be the relative formula mass of ammonia, which is all of this. Okay, and you can see here that the mass on the left-hand side, which is going to be our bottom, is going to equal the mass of the right-hand side, so this is going to be 1, hence 100%. So what about when it's slightly different? And we have the reactants going into multiple products and only one of them is what we're interested in. Let's have a look at an example. Okay, so let's have a little look at making ethanol. Now, ethanol is a really important chemical used in all sorts of different things. Certainly at the moment, one of the uses that you may have heard of for medicinal alcohols is in sort of hand sanitizers and wipes and sort of keeping everything disinfected. So it's got some pretty important uses currently. And will always have important uses. Now, there are two ways of making ethanol, and it's a really good way of talking about how atom economy sort of comes into the discussion of which reaction to use. So the two ways of making ethanol is that we can have an organic compound called ethene, and we can react it with steam. And the other way is fermentation. And it's actually a really common question to compare these two different methods. So let's just look at the chemistry of the two methods when it comes to their atom economy. So let's start with ethene and steam. So if we were to look at ethene and steam, what we would have is we'd have C2H4 plus H2O going to C2 H5 OH. Okay, that is the equation for ethene plus D. So thinking back to the last little bit that we talked about with ammonia, you can see that all of the reactants here become the product. So this, without doing any calculations whatsoever, has 100% atom economy. Fermentation is a little bit different. So a little bit of cross-curricular here. Formula for sugar or glucose, C6, H12, O6. And then to this, okay, it just turns into ethanol, C2H5OH, and also carbon dioxide. We just have to balance this out as well. Now here we've got one of those examples whereby our reactants make two different products. Now we're only after one of them, and the one of them we are after is we're after the ethanol. So let's now work through an atom economy calculation to see what we'd have. Okay, so we've got these two numbers here that we're interested in. So remember, the atom economy equals, okay, the thing that we're interested in, okay, which is our ethanol here. Now, ethanol has an MR of 46. Okay, now, one of the things we've got to remember here is there's actually two of them. So, in our calculation, it's the sum of all the useful products. So, we'd have 46 multiplied by 2. I get the 2 from the big number here. Divided by, okay, the mass of the reactants. So, the reactants is just glucose. Now, glucose is an MR of 180. This might be something that you'd actually have to work out as part of a question. So then all we do is we just multiply that by 100, plug it into your calculator, and you'd get the answer of 51.1%. Okay, so here you can see that we've got these two methods. We've got ethene and steam, which is 100%, and fermentation, which is 51.1%. You might be saying, well, why don't we make all our ethanol using fermentation? Well, chemists would have to take other things into consideration as well, conditions for the experiment. And I'll talk about that in a different video about how to answer those kind of questions where you're asked to compare two methods. Okay, but for now, we're just looking at atom economy. So here we can compare the two by saying that ethene and steam has 100% atom economy, whereas fermentation only has 51.1% economy. So now it's over to you. Why don't I give you a question and you have a go at it? Okay, so here are your two reactions that I'm going to get you to work out the atom economy of. The first one, okay, is making water from hydrogen and oxygen. The second is making copper sulfate from copper carbonate and sulfuric acid. I've given you all the information that you need in order to answer the questions. So, give the video a pause and good luck. So let's talk through each question. Okay, first off, what's the atom economy of the following reactions? Making water from hydrogen and oxygen. Well, the first thing you had to do here was just actually write out the equation for making water from hydrogen and oxygen, and hopefully realized just by looking at the equation that this is 100% atom economy, because on the left-hand side, all of the atoms on the left-hand side make our product that we're after on the right-hand side. Second one, just a little bit more calculations really, okay? We're interested in everything on the left-hand side of the reaction, and then our product that we're interested in is the copper sulfate here, okay? So we need all of this, the MR of all of this, and this side here. So if you did some calculations, you would have found out that copper carbonate, CuCO3, okay, had an MR of 123.5. Sulfuric acid, H2SO4, has an MR of 98. So the total on that side would have been 221.5. For our copper carbonate, for our copper sulfate even, CuSO4, okay, this equals 159.5. So our calculation for our atom economy, okay, would equal 159.5 divided by 221.5 multiplied by 100, which to three significant figures is 72.0%, and that's to 3SF. Okay, so I hope those questions have helped. I hope you feel like you've got a little bit of a grasp of atom economy. Please ask any questions in the comments below. But as always, please like the video, subscribe to the channel. That would be awesome. I do appreciate your support. So this is sort of concluded the yield and economy side. We'll talk a little bit about how to compare different methods in the next video, and then we'll talk about titrations and concentrations after that. But as always, thank you very much for watching, and I'll catch you in the next video.